In the news and media, quite often we hear artificial intelligence being compared with machine learning. And although there are some similarities between artificial intelligence and machine learning, here in the very first video on this YouTube channel, I wanted in 1 minute to explain the difference between the two. Because machine learning is just a subset of AI. AI, in general, it's a machine that is trying to develop the ability to imitate intelligent human behavior. In other words, AI wants to be human. AI is a machine that wants to behave and act as human beings. Machine learning is different. Machine learning is an application of an AI that allows system to automatically learn and improve from experience. In other words, machine learning is just a machine trying to teach another machine how to identify patterns, analyze data, and develop solutions based on the data analytics that is available. Artificial intelligence in the past, in the many years ago, they had a different approach based on logic and pure mathematics. And the idea is that if you can send artificial intelligence on a spaceship somewhere out in space, out of this world, then the AI, if it encounters an unknown phenomenon of some kind, the AI would be intelligent enough without any data to analyze the phenomenon. So the spaceship would identify what's happening with the phenomenon and it would provide a solution, or at least inform the crew of the type of problem that there is. And we can see this in Star Trek movies quite often. And that AI was based on logic, not on data, because quite often when that spaceship would go into space, they wouldn't have data on those phenomena because they're not happening on planet Earth. But that was abandoned, and the best approach that we can find on that is ELIZA. ELIZA was a personal therapist for mental health, that you would ask a question and ELIZA would answer. But it's very simplistic, and you can still find some copies of ELIZA that you would play with, but you would ask, ELIZA would ask you a question like, how are you? And then you would say, I feel bad. And then it will ask you again, like, why do you feel bad? And it would analyze it that way. So that approach was abandoned. ELIZA is just a remnant from the past. The current machine learning algorithms are the best version of AI that we have. And that is why machine learning is commonly referred to as AI. In the future, we might get another attempt to build logic once we get the quantum computers. But until that happens, we are stuck with the machine learning. And machine learning, it's most of the AI chats that you get from Alexa, from ChatGPT, those are all based on machine learning algorithms. Now, deep learning, also within deep learning, there's something called reinforcement learning. And this reinforcement learning is a little bit closer to the logical explanation, because we're going to explain in the next section the difference between machine learning algorithms. But reinforcement learning is not that dependent on data. Reinforcement learning is learning from the events that are happening in the world. So this is a brief explanation of what is artificial intelligence and how is it different from machine learning. Machine learning is just one approach for artificial intelligence, and in the future we might have multiple different approaches, and machine learning might be just one of those. We might have a variety of different approaches, but machine learning is based on data. Without data, we cannot train the algorithms. So machine learning is not going to work without data. If you have machine learning algorithm and you're trying to resolve problem that we have never encountered before, machine learning won't be able to help you. With the machine learning, you have three different types of algorithms. One is the supervised learning, the second is the unsupervised learning, and the third is the reinforcement learning. And those are the three categories of machine learning that they're most famous. If you ask, and I did ask, University of Oxford professor, I work in the University of Oxford Department of Computer Science, and I asked some of the leading professors in this area, can you learn all the machine learning algorithms that they exist? And the answer was no. Those people, those old professors, that they've been working their entire life in machine learning and artificial intelligence, from the first day in university until they're close to retirement now, they still don't know all the different algorithms. So in this short video, you're going to be able to learn what's the difference between the categories of supervised, unsupervised, and reinforcement. And you're going to be able to pinpoint, if you have a problem, what is the best approach for that specific problem, what algorithm, what machine learning algorithm is the most suitable to resolve those problems, because they have unique features and characteristics. Looking at supervised learning, what is the characteristics of supervised learning? Supervised learning requires data, and that data needs to be labeled. In other words, if you have an apple and you want the algorithm to be able to identify apples, you have to label those apple. And then you have to identify different fruits, for example. This should look like a pear. And then you would have apples and pears, and you would train the model to learn how does apple look and how does a pear look. And then you would feed unlabeled data file to the model, and the model would be able to determine how many apples and how many pears do you have in that file. That's the very basic of supervised learning. Supervised learning has multiple applications. Some of those are image recognition, or another one is voice recognition. But specifically for image recognition, if we're looking at how supervised learning can help with image recognition, imagine that you have loads of x-rays from some kind of a medical illness, and you have already diagnosed those patients that they had that specific illness. Well, supervised learning is the best approach here, because you know the illness and you have the image. You would feed those images with a label explaining what kind of illness it is to the supervised learning model, and then you would, once the model has been trained, it would be able to recognize that specific illness. Then you would, when a new medical image would come, you would just feed that image to the model, and the model will give you positive or negative result if that image, that x-ray that you've sent, has that specific illness or not. This would reduce a lot of time in the medical profession, and there's various other implications that you could apply supervised learning. Actually, although this reinforcement learning is far more advanced than supervised learning, we can expect that in 2024 and in the next few years, the supervised learning will still predominate the market, just because enterprises have loads of data and they're trying to make value out of that data. So if you have the data already, then this is the best approach for you to analyze that data. Unsupervised learning is different. With unsupervised learning, we have no labels. So we have apples and we have pears. They're all combined in an image, and there's loads of different data points there, but they have no labels. Well, the value of unsupervised learning and why it's a different algorithm than the supervised learning is that with unsupervised learning, you can categorize that data like we can see here in the image. So the algorithm would take and categorize it into different categories. And then you could look at those categories and you would know which category has the biggest representation. So if this category is apples, then the unsupervised learning will detect that and say there's a category here of things, and there's loads of them. So then you would, when you look at the data set, you would know, oh, okay, there's apples there. So this is how unsupervised learning works. And when is it useful? It's useful when you have a very large data files and you don't want to analyze them, or you cannot analyze them, or you don't have the time or the resources to analyze them. Then you just feed those data files to the algorithm, and the algorithm will come up with this kind of categorizations for you. It will organize the data and it will tell you how many different things there are. And it could do this in various different ways. It could do it with as a percentage, or as just as a category. But in other videos, we're going to be talking more about that. Now, reinforcement learning, which is the last category of the machine learning models that we're going to be talking about. Reinforcement learning is the most promising category at this present, and it's very close to independent, in a way, AI. So if we had an AI robot would definitely use reinforcement learning. because that robot would need to learn from the environment and how it interacts with the environment. As when we see with supervised learning, that is just a machine learning algorithm that has been trained on the data. It does not get any more input in the future. So once you have trained the model, you have deployed the model, that is it. With reinforcement learning, it's constantly learning from the environment. It doesn't require any data. So reinforcement learning is used in cases when you have no data. It's just that you have an agent, and this could be a robot as it's in the picture, or it could be an autonomous vehicle, it could be Raspberry Pi, it could be IoT device, it could be many different things, IoT device. It would still need to contain memory. So the robot, the memory of the robot would perform a specific action. That robot is the agent, the learner. And based on that action, it would observe how our environment react, and it would process the state, and then it would get either reward or a penalty. By getting a reward, if it's successful, the model learns just by those rewards. And one I don't even know if it's true or it's just a speculative thing, but in the US Army, they have this simulation training when they were training pilots, like AI-based machine that was flying and performing certain bombardments. And at the very last moment, just before it executes the bomb, the controller would request that the pilot returns, the AI returns the battleship back. So after 2 or 3 attempts, the AI got upset and bombed the controller because the AI was not getting the reward. AI wanted to get its reward for completing the task. The task was to destroy a certain base, and the controller would continuously retract the AI just before it destroys the base. So the AI got angry and destroyed the controller. And I'm not certain if this is true or not, but it's definitely a possibility because the agent is learning from the action, and the agent requires the reward. So without the reward, the agent cannot learn. So we have supervised learning, we have unsupervised learning, and we have deep learning or reinforcement learning. Those are the 3 main categories that we spoke about in this video. And within each category, there's various different algorithms that could be used. That would be for another video. But the basic difference is that the supervised learning require data that has clearly defined output. It's a label. So the label should be specifying a specific target. So to identify how many apples there are, to identify the house price in this neighborhood. Without a target or without a label is very difficult to train a supervised learning algorithm. Unsupervised learning is different. It does not predict or find anything specific. It just aims to identify distinct groups. So with unsupervised learning, you can analyze the data and come up with the different categories. So category 1, category 2, category 3, and then you're going to know which category is smaller, which category is bigger, which category is the biggest. But with supervised learning, you can make predictions. So that's the advantage and the strength of the supervised learning, because it's going to use the labels and the data that you provided to make predictions about the future. And with deep learning and reinforcement learning, this is a reward-based learning. So the machine learns how to act in a certain environment and gets a reward. This is why if we ever have a humanoid-looking robot, that robot is probably going to use reinforcement learning. But also there's some risks here, because that reward, the reward over here can be a little bit problematic for building AI systems. And if you're interested in AI security content, then follow this channel and you're going to be getting notifications about that. Education is expensive. So I work for the University of Oxford, and if I was doing this for Oxford, they would have been paying me money, and students would be paying a lot of money. I'm trying to do something for free that people would be getting education. I believe education should be free, but I'm gonna need followers, because if I get 1,000 followers, YouTube might pay me like £2 or £3 per video. I don't expect much more than that, but I need 1,000 followers, and at the moment I have 0. So if you have watched it all the way until now, then please click follow and subscribe to the channel.